It's Thursday, the 29th of August. My name's Juan Brown. You're watching the Blancolirio channel. Welcome back to the hangar. And today we're going to do the long-awaited, much overdue 737 MAX update. We're going to do a chronological review of the entire story as we know it, from the beginning of the 737 MAX development and the implementation of MCAS all the way up to date. For all you thousands of new subscribers, I want to welcome you to the Blancolirio channel. I've been flying for over 40 years, commercial, military, civilian, 20 years with the airlines and a bunch of different aircraft types, not necessarily by choice, but by economics as we continue to work through the lost decade of 9/11 through the Great Recession. I got time in both 737-800 type aircraft and the Airbus A320 series of aircraft, which is going to give us some unique perspective on the 737 MAX story. I've most recently been flying the Boeing 777 aircraft, long haul flying from LA to London, LA to Hong Kong as an FO, but I'm temporarily sidelined for medical reasons due to a excessive PSA count above FAA limits due to prostate cancer, which I've pretty well dealt with, but I gotta wait 6 months now following radiation and hormone therapy treatment to get an accurate PSA reading to resubmit my paperwork to the FAA to regain my FAA Class 1 medical. They've also granted me for Class 2 and Class 3. Which really stinks, but the rules are the rules. The 737 MAX story has completely rocked the entire airline industry. It's cost billions of dollars, thousands and thousands of delays in aircraft production and aircraft scheduling. We've lost confidence in our regulatory oversight of the entire industry, and let us never forget the loss of 346 lives. Like any disaster, this story is going to have a long chain of events by the time the final investigations are over. We're going to find Boeing aircraft poorly designing a system under pressure and unrealistic time constraints and making unrealistic assumptions about human pilot performance and shoving that system out the door in an effort to meet market demands in an unrealistic time constraint, and an unforeseen failure of this system, or a not very well thought out failure mode of this system, subjecting 2 air crews to an overwhelming failure that no air crew members, no pilots of no aircraft should have ever been subjected to. Though those crews did their best to save their aircraft, they did make a couple of mistakes in the procedure in an unrealistic amount of time to get the procedure correct in a very critical phase of flight that led to the loss of 2 aircraft and 346 lives. In the process of reviewing the 737 MAX and the MCAS system, we also want to clear up some common misconceptions that were initially promulgated by the mainstream media and spread through social media like wildfire by folks that really don't understand some of the basics about aircraft stability and aviation. Those basic misconceptions are this. 1, the MCAS is an anti-stall system. I hear this all the time on the media reports. No, the MCAS is not an anti-stall system. The pilots of Boeing designed aircraft are the ultimate anti-stall system. MCAS is a means to provide the pilots the control field inputs that they need to recognize an impending stall and recover from it. The other common misconception is, well, the 737 is an inherently unstable aircraft because of the design changes, the bigger engines. No, the 737 MAX is not an unstable aircraft. It cannot be an unstable aircraft as per the FAA design requirements for basic transport category aircraft stability. MCAS is not installed in the 737 MAX to meet the requirements of FAR Part 25.171 aircraft stability. Again, what MCAS is all about is an effort to get the new 737 MAX to handle and feel like previous iterations of the 737 so that all of these aircraft can be operated under a single type certificate rating. And that's very significant because this whole thing is about saving money. A single type certificate rating allows any pilot of any 737 to operate any other model of 737 because they all handle similarly enough. Why is this so expensive? Because me as a pilot, I can only operate one type of aircraft at a time. I got to get trained up on that aircraft. I got to get a type certificate rating for that aircraft that matches the aircraft's type certificate rating, and getting that rating takes at least 6 months of time off of the line and in the simulator, a very expensive simulator training program, and then several more flights in the actual aircraft itself with an instructor pilot to get fully qualified in the new aircraft. A new type certificate rating takes time and money to get your pilots trained up for it. The 737 MAX saga has so rocked the industry that even Southwest Airlines, who has built a business model based on one type of aircraft, the 737, is reconsidering their entire business model of this one type aircraft design. Southwest has 34 737 MAXs grounded, about 5% of their fleet. Before we dive deep down into this subject, let's review where we're at today. The 737 MCAS software solution has pretty well been worked out and is getting certified by the FAA. What Boeing and the FAA are working on now is a fundamental redesign of the flight control computer architecture of the 737. Traditionally, the 737 has had 2 FCCs, or flight control computers, on board the aircraft to help with various functions of the aircraft, like pitch trim and roll trim for automatic landings. Traditionally, the FCC's flight control computers on the 737 have operated one at a time. One FCC operates for an entire flight leg. Once that aircraft lands, the squat switch indicates the aircraft to switch over to the other FCC for the next flight. The squat switch is that little switch on the landing gear. The FCCs consist of 2 16-bit processors. In simulator testing, pilots and engineers were able to create a scenario where enough bad data input was fed to the single FCC to create a runaway trim scenario that took too long to recover from. If there was a problem with the FCC, that problem FCC would drop out and the other FCC would take over. What they're doing today is rewriting the entire architecture for the 737 program. By the way, the FCCs came around in the 1980s or so when the speed trim system, I believe, was implemented into the 737 design, and the auto land capability was begin to be introduced into the 737 design. Now they're rewriting the architecture on all the 737s so that the 2 FCCs talk to each other. And if one FCC starts indicating a problem or having bad data, both FCCs will drop out of the system altogether, leaving it up to the pilots to hand fly the aircraft without any additional computer interference. Now let's go back and review the 737 MAX from inception to today. Due to industry consolidation, we're down to just 2 manufacturers of airliner aircraft, Boeing and Airbus. And these 2 companies represent a fundamental difference in design philosophy. Boeing has a long tradition of building aircraft that are pilot-centered, using conventional controls to a control column that the pilot manipulates to get the feel for a traditional airplane. Having flown both aircraft, I prefer the Boeing pilot-centered design over Airbus. However, having flown the Airbus, I can see that Airbus is the wave of the future. By designing a fly-by-wire aircraft relying on computer systems, you can build in protections into this aircraft that will protect pilots from some of the most common mistakes that pilots make. Flying too slow and stalling the aircraft, flying too fast and exceeding the speed limits of the aircraft, overbanking the aircraft. So these are some of the examples of some of the protections that Airbus offers.
By using a fly-by-wire side-stick controller, Airbus design doesn't need to worry about control, feel, or feedback, and instead let the computers take care of it.
Both design philosophies, both types of aircraft are inherently stable. They do not need the computers to maintain stability. Unlike fighter-type aircraft, fly-by-wire aircraft, fighter-type aircraft are designed inherently unstable to give the increased maneuverability that they need for combat flying. For years, one airline, American Airlines, was heading for an all-Boeing fleet. With mergers and acquisitions and bankruptcies in the airline industry, American Airlines ended up pairing with US Air. Overnight, American Airlines became one of the biggest operators of Airbus aircraft in the world. When it came time for American Airlines to upgrade its fleet with newer aircraft, American Airlines went to Boeing Aircraft with a request for a new 737, and it was that request that got the impetus for the idea of continuing one more swing at the 737 design and creating the 737 MAX.
Even with the new 737 MAX, American Airlines will continue to operate a mixed fleet of Boeing and Airbus aircraft.
Now let's take a moment to talk about aircraft stability. Aircraft stability on the longitudinal axis, pitch axis, is achieved when the center of gravity is located ahead of the center of pressure. The further this distance is, the greater the stability of the aircraft. The heavier the controls will feel for the aircraft. The closer that the center of gravity is to the center of pressure, the less sensitive the controls will be, and the less stable the aircraft will become. Here in the Mighty Luscombe simulator, in straight and level unaccelerated flight in a trimmed condition, there is zero force on the stick. It's perfectly balanced. We are in a perfectly stable condition. Per FAR Part 125 design considerations, if I want to fly this aircraft away from a trimmed condition, I'm going to feel that untrimmed condition in the stick, and I'm going to feel it by weight. But by the FARs, that weight needs to be something on the order of about 3 pounds of stick force for each 10 knots away from a trimmed condition. In other words, in the Mighty Luscombe, if I was at 100 knots or 100 miles an hour straight and level, and I pulled the stick back to 90 miles an hour, it would require about 3 pounds of stick force to maintain the 90 miles an hour. That gives the proper pilot feedback that he is flying in an out of trim condition and gives the aircraft its feel or handling characteristics. The trick with the 737 MAX is they need to make that aircraft handle and feel like previous iterations of the 737. In other words, these stick forces need to be similar to older model 737s. Conversely, if I'm cruising along straight and level unaccelerated flight at 100 miles an hour and I want to push the nose over and descend at 110 miles an hour, it's going to take about 3 pounds of forward stick pressure to maintain that 110 miles an hour. Until which time that I decide to retrim the aircraft and reset the new speed of 110 miles an hour and relieving the stick pressure back to zero. The same exercise can be done with pitch and power. 100 miles an hour unaccelerated straight and level flight. I want to maintain 110 miles an hour by increasing the throttle. Once I get up to 110 miles an hour, I'm going to need to hold forward stick pressure to maintain that 110 miles an hour until I retrim the aircraft to relieve the stick pressure. these stick pressures and handling characteristics need to be maintained throughout the entire operating envelope of the new 737 MAX, including at the very edges of the envelope, like right at the point to where the aircraft stalls. What engineers found with the 737 MAX, with the new big engines, efficient engines, and the bigger engine nacelles, is that at the very stalling speed of the envelope, at high angles of attack and high power settings, the stick forces on the 737 MAX were too light. They did not meet the standards of 3 pounds per 10 knots difference from a trimmed state. In other words, the handling characteristics of the new 737 MAX at this one very corner of the envelope, particularly in the case of an accelerated stall, which I'll explain here in a minute, did not meet the same handling characteristics, or did not match the same or similar enough handling characteristics of older 737s. And thus, MCAS was born, Maneuvering Characteristics Augmentation System, to augment the controls of the 737 under high AOA, high power, tail heavy conditions to match that of older 737s. So the very initial iteration of MCAS was simply designed for this one specific corner of the envelope. They achieved this by enhancing the speed trim system with the addition of MCAS that would override the stick inputs and the control column cutout switches and push the nose over at a fairly reasonable rate of, I think it was about 2.5 degrees per second for one time shot, just to give the pilot that little bit of nudge of control wheel pressure to give him the feel that he's getting close to a stall. It's not to prevent the stall, it's to give the pilot the clue that he's getting close to a stall so that he can recover from it. So MCAS was given just a little bit of control authority because this was a relatively high-speed stall event, and you don't need a whole lot of pitch trim to correct in the event of a high-speed stall. So MCAS, this very original iteration of MCAS, was approved. In the industry, ODA, or Organizational Designation Authorization, has been the standard of the industry for many years. This is how the industry oversight happens. The FAA by itself does not have the manpower or the knowledge to keep up on the latest on aircraft designs, especially when it comes to computerized aircraft flight controls. So within the company, in this case Boeing, there are representatives that work for Boeing that are designated as part of the organizational have the organizational designation authorization to ensure that Boeing designs comply with federal aviation regulations. There were at the time 2 FAA inspectors assigned to Boeing to oversee the 737 MAX program. These were 2 very experienced guys, and they soon found themselves bored or not doing much more than pushing paper around for the FAA, as the ODA guys and the designated engineer representatives were taking care of the lion's share of the work. So soon these 2 highly experienced guys left the FAA for another job, I assume, or for some other position. In the meantime, these 2 experienced FAA inspectors were replaced with 2 younger recruits, and then things changed. The MCAS design changed. That word apparently did not get back up the chain of command. Here's how MCAS changed.
Later on down the line, once the original iteration of MCAS had been approved, engineers found that the new 737 MAX had undesirable handling characteristics in low-speed stall conditions. The flight controls, once again, were too light to give the correct, proper pilot feedback that they were approaching a stall. So the power of MCAS was strengthened dramatically while retaining the original architecture of no redundancy and using only one angle of attack indicator input. The speed at which MCAS was allowed to retrim the stabilizer was increased greatly, and MCAS was allowed to make multiple inputs until the stall condition was recovered. If left unattended, this version of MCAS would drive the stabilizer to its full nose-down position in less than 1 minute, which could easily overpower the elevators and thus the aircrew in the event of an MCAS malfunction or an AOA angle of attack input malfunction.
A catastrophic failure, according to the FAA, is something that happens on the order of 1 to the -9. In other words, 1/1,000,000,000th of a chance that that event could occur. This new iteration of MCAS obviously had the capability of creating a catastrophic event. However, much of this was overlooked because Boeing felt that the pilots of the Boeing 737 would be able to easily disable the system using the standard old runaway trim procedure and hitting the stabilizer trim cutout switch to cut out, turning off the power to the stabilizer trim motor and disabling the MCAS system. And the problem is, an MCAS malfunction does not present itself like a traditional runaway trim. Instead, it presents itself like an unreliable airspeed or unreliable instruments indication with a whole host of lights lighting up in the cockpit, completely confusing the aircrew. Also, too, certain warning lights were deemed optional equipment at the time and not made mandatory to help pilots figure out what was going on with their aircraft. Oh, in hindsight, with the absolute Christmas tree of lights going off in the cockpit, it would be hard to say if those additional features would have really helped these two crews in these two accidents. All of these failed assumptions and miscalculations is what set us up for the disasters that followed. Now, part of the fix for the MCAS is to return MCAS to its original design format and removing much of its strength, and also building in the required redundancy that a modern aircraft requires. MCAS now requires input from 2 AOA indicators as opposed to the original 1 single AOA indicator. If one AOA indicator disagrees with the other AOA angle of attack indicator, remember the little vanes mounted on the side of the aircraft, by more than 5.5 degrees, MCAS is turned off completely. MCAS can no longer command multiple nose-down trim inputs, and MCAS can no longer provide enough trim inputs to ever override elevator input. Once the 737 is ungrounded, pilots are still figuring out how much training they should get for this new design. It's probably still going to be an hour or two on an iPad, and then once time each pilot rotates through their annual recurrent training, they will then go through and experience MCAS-specific malfunctions in the simulator. Well, I hope this gives you a better understanding of the 737 MAX saga to date. This is the 11th video in a series of exclusive videos I've been doing on the 737 MAX from a pilot's point of view. Thanks for your continued support of this station through YouTube subscriptions, Patreon, and PayPal. Be sure and check your notifications window that you got it set up the way you want it for notifications for more updates on this ongoing story. See you here. Man, that was a long one. I'm thirsty. For you new subscribers, the question frequently comes up, what's with the name of your YouTube channel? Where did that come from? Well, this originally started out as my wife's channel. My wife Jenny, she comes from Spain, and many years ago when she started her YouTube channel, she had to dream up a name really quick, and she came up with the name Blancolirio, or White Lily. I started posting videos on her channel, and a couple of years ago this channel really took off with the failure of the Orville spillway just 35 miles away from here, and the rest, as they say, is history. See you here.